Hey, what's up, everybody? You are listening to the Data is My Science podcast, the show that makes data your passion. This is your host, Dapper Data. I have an extremely extraordinary, focused, driven guest on the podcast today. I want you all to make sure you tune in, make sure you really focus in, make sure you take notes. Okay, you got to take notes. Okay, because this person, this young individual, is going to blow your minds. As you all know, we always talk about whether it's high level, whether it's real deep dive, right? We'll dive into data science, we'll dive into data, we'll bring on people that are restaurant owners that never have touched data in their life, right? But introduce them to something called data science, right? Introduce them to data and analysis, being able to focus on something that we know that is a passion of ours, or a passion of mine, right? And the audience, and really help them understand how they can use data in their everyday life, right? We want everybody to know that data is important, right? And that's why I brought this podcast to you all, but today, right, this is different, right? Because we're not diving into deep programming languages, right? We're not talking about supervised and unsupervised learning. We're not talking about, Python programming, R programming. We're not even speaking to somebody that is like maybe the CEO of a data thinking company, right? But maybe has never used data in their time. Or we're talking to somebody that has probably covered the gambits, right? Has probably covered multiple facets, and at such a young age, we're going to talk about how to intersect data science, neuroscience, and artificial intelligence all in one, right? We're gonna talk about how somebody has been able to do that at an early stage in their life, and is making a true difference in their world right now. And I like to bring on these guests, so I'm bringing on Keiland Cooper. Okay, say hello, everybody. Say hello, Keiland.
Hey everybody, glad to be on.
So Keiland, right, is a cognitive scientist at the University of California, also a National Science Foundation fellow. He's worked on multiple research projects, and he'll be able to tell you some of the coolest ones that he's done so far. And he's co-founder of something called Continual AI. We're going to start off with that because I'm being selfish. I want to hear about it more than anybody, So I'm not even going to say that the audience wants to hear about it, But that's one of the largest global artificial intelligence research nonprofits spanning academia and in the industry right now, And so, without further ado, please welcome Keiland Cooper. Keiland, tell them a little bit about yourself.
Yeah, so hi everybody. My name's Keiland Cooper. I couldn't have introduced myself better, and I don't even believe that I did half of those things. Um, I'm super happy to be on and to talk with you all. Just a little bit about what is probably all boils down to my addiction to data, is probably what I would call it, and learning from data. So much so that I think it's funny that you brought up restaurant owners, because we were just talking to one of our friends who owns a restaurant, and we're like, how can we like learn from like some of their data they have? And he's like doing everything on paper, has like no has yeah, and so that's what we're so like, all right, we gotta implement some data collection
Oh my goodness.
programs. We gotta get you spreadsheets like at the start, and then maybe we can graduate up. And so now we're getting like all these pictures of like receipts and stuff from the restaurant, just like in JPEG images, and like trying to go back and put them in spreadsheets to try and make sense of stuff. So
Man. Where's that located? Where's that restaurant located?
you can't. It's in Japan.
It's in
So
Japan. Okay. I own a restaurant. I didn't tell you this in Ghana, in Africa, in Accra.
oh, that's so cool.
Yeah.
Yeah.
And I do a lot of the data science stuff there, right? A
Ah.
lot of the data analyst work and stuff like that. Being able to do things. I'll give an example, right? Having a car drive past, right? If they've already been a part of the loyalty program, being able to give them a text message, right, to say, "Hey,
Oh,
look,
like location-based
yeah,
marketing to yeah,
exactly,
yeah.
exactly. Or being able to speed up, right? The server, the every the being able to do timing analysis, stuff like that. Being able to make sure that they get things sped up faster, right? Just
Yeah,
to
yeah, yeah.
deliver the menu items faster. But yeah, man, Oh man, that's awesome. Man. Sorry, I interrupted you. Go
Wait,
ahead.
no, that's super. No, I think that's, yeah, it's like a super cool problem, and like I think it's because like we eat 3 times a day or 2 times a day, so
Right,
you know what
right,
I mean. So like you're always there, and you're always, and whenever you're like, my food's too slow, I could probably fix this, right?
right, right.
uh,
Man,
so
so
anyway,
I want to
continual AI.
continue AI, right? You know, we have to start off with that because for me personally, I am currently in my final phase, right, of my doctoral degree, right? We talked about that before. And I hear research, right? I think I belong there. I need to be part of that, right? I need to solve problems, right? I need to look at how to better my dissertation right now. That's
Mhm.
the part that I'm in, you know. Um, talk about Continual AI. You know, what is that about? What is it doing to impact the world?
Yeah. So the reason I kind of got started in this area was I was doing neuroscience research as an undergraduate and all that, but I was really interested in the idea of like how do we read, right? So that is good. Like if I wanted to design like some AI system theoretically to read every book in a library or something, because I sure as heck can't, right? Like you want to learn all these things, and like you're rate limited by however fast you can read. And I was like, so
Right.
what would an AI that could read look like? Um, and just around the same time I was thinking that, I went to a talk by one of the professors at the school, Mike Jones, who does that research. He studies like natural language processing systems in both humans and in kind of like the natural language processing algorithms, and kind of compare and contrast the algorithms. And one of the problems that they were facing was that when you used like Word2Vec by Google, so this is the underlying neural engine that kind of supplanted the standard natural language processing algorithms, it overnight transformed Google Translate from being kind of crappy to being like, wow, that's decent.
Mhm.
Um, and we were using Word2Vec, but the issue was that depending on how you trained the algorithm, so you get this big text corpus, you feed it into the algorithm, it learns the associations between the words, and that's some approximation of semantics in the sentence. It's
Mhm.
rudimentary, but in practice it works. But what we found was the issue was depending on how you trained that neural network, um,
Mhm.
the meanings of the word to the network would change. And what we ended up showing was that this was a long known problem in neural networks, far beyond anything we were doing. This has been well known since the late 60s, 70s, catastrophic forgetting,
Mhm.
which boils down to the fact that you take a neural network, deep neural network, you train it on data. So say you have like your standard image classifier that's going to look at dogs versus cats, and you
Mhm.
train your network on dogs and it learns dogs, you get 90% accuracy. That's great. You take that same trained network on a new problem, say cats, and then you train it up on cats, you test it on
Mhm.
cats, 90% accuracy, you're doing great. But then you take that same network and test it back on dogs, the first data set that you gave it, and it
Mhm.
completely forgot everything that you had given it. And so
Yeah.
what happens is, depending on the order of how you train your network, the network's going to overwrite any of its learned associations to whatever the most recent data set is. This is a
Mhm.
big problem because, if you want to build these grand AI machines that can do all sorts of tasks, that's like the chief complaint for AI, right? It's like, oh, it can play chess to superhuman capabilities, but can it, do anything else? And the answer is almost
Right.
always
Right.
no. Yeah. Um, and so this is like the problem to solve: catastrophic forgetting, which is probably the main impetus for continual learning as like a research area, kind of far beyond our organization, which is just designing tools and new algorithms and just trying to understand in the beginning, how can you make AI, specifically neural networks, learn multiple tasks without forgetting the old ones that they had learned,
Mm.
right? And to me, like, in a practical sense, that's a useful problem in terms of energy costs for companies, because you have to keep retraining on the entire data set every time.
Right.
So there's a bunch of energy for companies. It's a
And
greener
then
way
using
to.
the historical data, right? You know, to continue to drive the future.
Yeah. Or if you don't have access, so like a lot of medical domains, you only have limited access to your data because of privacy laws. So you can't just like ship the data to and have it sitting on someone's server because you have some time limited. So you would want to train your algorithm and like retain what you've learned and then add to that consistently. But if you're constantly forgetting whatever you recently learned, then you have to retrain on the entire data set or corpus.
Right.
So there's the practical sense, but in the, we're all in this because we dream of having like Jarvis or like the grand AI that can do anything. That's a huge hurdle for any like general artificial intelligence system. You want an AI that can just, you set it loose on the world and it'll just keep soaking up information like we do. That's what,
Yeah.
what we do. Hopefully
Yeah.
after we have this conversation, you're not going to forget like your dissertation or
Right.
forget some other thing that led into this. I mean,
Right.
there's like
Well, I would say you may make me change my topic. It's too late for that though. But yeah.
It applies to everything. So yeah. So anyway, I met up with a postdoctoral scholar at the time. His name was Vincenzo Lamonaco. He's now a professor in Italy, and we got to talking about this. This was like his main research area, and we had a shared interest, and we decided to say, hey, there's like this is like a new burgeoning field that was just kind of organizing all of these little problems in machine learning at the time. So catastrophic forgetting was the big one, but there's also like transfer learning, which applies, representational drift, and some other issues. And we're like, what would a community of these people look like if we all just put them together and they could just talk and share their ideas? And so we built a website. We called it Continual AI because continual learning is kind of the grand goal for this.
Right.
And it kind of just took off. I think, a little bit it was just people are interested in what this could be. Like, what would those algorithms look like? A lot of people were practitioners and they were facing these problems and needed advice. A lot of students who are just interested in AI in general, and this was a cool way to get involved. And so we've kind of built this community around this topic in AI that's really just taken off and grown over the last couple of years. And it's been really, really exciting to see all of the things that people are doing and sharing and building.
Yeah, and that's amazing, and I did a lot of reading on what you all are doing, and um, there's so much that artificial intelligence can do to impact education, right? And we don't talk about it as much, right? We don't talk about how AI can impact, education at every level, right? From pre-K all the way up to doctoral degrees, right? When you talk about research, doctoral degrees, things like that's really cool, But even when you're talking about from a pre-K to the 12th grade point of view, that's something that I personally have shown some interest in, right? Trying to bring AI involved in that, where I'm thinking about different ways that children learn, right? They have different ways that they learn, and to be able to pass some of these tests that are out there, right? It may be focused on one learning method versus another, and when they decide to take that test, they may struggle because that's just not the way they've been taught through a teacher, throughout the entire time, and then they take the test and they're like, man, I'm more visual than audio, right? Or something like that. And I'm sure that AI can make some type of impact in this world when it comes down to those things and being able to help kids transition, throughout pre-K through 12th grade or something. Do you think so?
Yeah, I think so. And there's actually where I am now at the University of California, there's a lot of really interesting research that other people are doing on that sort of thing, like AI assisted education technology.
Yeah.
And it's really cool to see because like I remember like I grew up like right at the like dawn of when people were trying to like put some lessons online, and it wasn't but like some of the things they're doing now are just really where like you're learning exactly like where, like say math is like where exactly are the students struggling in, and like the machine will learn and then it'll like target the questions towards those deficits and try and build those up and not worry about some of the other things. And really
No,
awesome
that's amazing,
results.
right? I wish I had that. when I was when I was younger, right?
Yeah.
I'm a
And
visual learner, and
yeah,
I would love to figure out, if I'm sitting next to somebody in class and they're learning the same thing but differently, right? Maybe they're audio learning and they're saying, look, what is it, like kinetic or something like that? Whatever it is, you're able to learn maybe a different way, but the same thing, right? To get to the same point, that we're all trying to get to. It would be amazing, right?
it really would be. And like some of the results are like people are learning better than you would otherwise because you have that kind of targeted help. And I mean, like in a practical sense, I mean, yeah, that's good because a teacher, for example, if you have 30 students in a classroom, you would like to get to know each student and know exactly where
Right.
they're struggling or how they learn, like if they like to have examples worked out or whether they like to, see the big picture or they like to like memorize, you know what I mean? But like,
Right.
teachers aren't paid. They have like
Yeah,
a bunch of classrooms and 30 students times in periods is a lot of people to try and keep straight while
exactly.
also doing everything else. And so hopefully like these things over time will just at the very least get like take a little weight off their shoulders. And
Yeah, I'm sure it will. I'm sure it will.
yeah,
So, all right. So you have done a lot of research within neuroscience, right?
yeah,
And we talk about how there is a connection to artificial intelligence within neuroscience, right?
mhm.
Where do you see, based off of your research, the biggest similarities and differences between those two?
Yeah. So I like to think of what I'm doing now as kind of like a feedback loop.
Hmm.
And it's always existed since I would say maybe the dawn of AI, where what we learn from neuroscience and how the brain works ends up being applied to build better AI algorithms and smarter algorithms. And then you take those algorithms, and especially nowadays, you reapply that to neuroscience and use it to learn more things about how the brain works, whether it's on the modeling side or even as tools. Like some of the recent stuff we're doing now is using deep learning to help
Hmm.
decode some of the spiking activity of what the brain is doing. And we couldn't have done this without deep learning. Some of the existing algorithms just weren't strong enough and just couldn't pull out some of these patterns. And now we have really good tools, just again from like a data analysis perspective, that can do these things. And so it's only going to get, it's only going to get stronger and stronger as we learn more about how the brain works, build better AI. AI helps us learn more about how the brain works. Um, but it's always existed. Um,
Oh, even before we start talking about it now, it's been existing for some years, you're saying.
Yeah, since I mean, like everyone talks about the AI winters, but if you go
Yeah.
back and if you look at some of like the early like say for example like the deep neural network papers,
Hmm.
they're usually called connectionist models. And what those connectionist models really were they were cognitive scientists or half of the time psychologists really, who were just trying to model their data in with some tool. And so these are people who are working with people and they're kind of on the more mathematical psychology bent. And usually they fit their data with like regression and stuff, but they want
Hmm.
to have a little bit, more biologically plausible model. And so they built these connectionist models to like help model their data. Um, and so if you look at some of the like 1960s papers and like the earlier years of neural networks, those are pretty much the entire theme. Even like Geoffrey Hinton, who's like like
Yeah.
if you read his early papers, they're basically cognitive science papers. It's not you don't really see machine learning. It's more like trying to
Right.
fit some psychological data, and this is the model that seems to work.
They're not
Um,
using necessarily the technology in place, right? They're not using the tools and stuff like that, but they have the same vision, right? They have the same mindset that we have now today.
yeah, yeah. I think there's been kind of a divergence. I mean, it still exists, but I think what happened over time is that statisticians and computer scientists and people who have real problems in the real world, to solve, and they're not just trying to figure out how the mind works or psychology.
Mhm.
They're like, these just so happen to be a really powerful function approximator and really powerful statistical learning machine, and
Mhm.
like, you know image classification was done, by computing features by hand or something else. And then when you found out that YouTube could learn an image of cats with like some,
Right.
right? You're like, well, okay, maybe this has some promise. And so I think it's kind of moved a bit from that kind of roots of trying to use these as a model to understand psychology or neuroscience, to being this strong tool of artificial intelligence to solve, like, AI is everywhere now. You hear it everywhere. And whether or not we want to call it AI, it's doing a lot of stuff.
And I see it, sort of emulating, right? Human intelligence, right? I I don't know how far it will be to where, or how long it will take to get to the point where it may take over. And I guess we'll talk about that a little later because I definitely want to know your thoughts on that. But yeah, I think about some of the impressive features that come along with when you're blending the two, right? And I think about, self-driving vehicles, right? Tesla, trying to deal with that, right? And that reliable sort of like object recognition that you have
Mhm.
in place, and being able to do things like detecting breast cancer, right?
Yeah, yeah,
Future and stuff, right? Faster than doctors can do now, right?
yeah,
So there's tools, there's things out there that is happening, right? And so it's for me, it's mind blowing. You're doing a lot more research in a lot of the field, they're interconnected to, and I just don't know if there's going to be a time where you say, hey, you won't be able to tell the two, right? Or you won't be able to tell the difference between the two.
yeah, yeah. I mean, it's kind of a joke. I don't know, a joke in the AI field that, like, there's a problem that people pose. So, like, for example, at one point in time, chess wasn't solved. Nowadays, you download chess on the App Store and you can play the most advanced AI, right? But, like, imagine a time when chess wasn't solved and people say this is like the height of human intelligence. Chess is a hard thing to learn. AI learns chess, and you're like, wow, that's really cool. Look at it learn. And then the second that somebody goes and says, oh, well, this is just tree search. You're just searching through all possible combination. And then and you're like, oh, well, that's not that interesting. It's not that smart. It's just
Right,
really
right.
fast. And you can be like, right. And so then you like move the goalpost up a little bit. And you're like,
Mm,
oh, well, we think Go or Jeopardy is strong. It's like, oh, it's not really Jeopardy. It's just like database searching through Wikipedia. Again, just
right, right.
research helping. Not that smart. Ken Jennings can like chew gum and play Jeopardy at the same time, or pour himself a cup of coffee. This thing can't. And so
Right,
then you
right.
move the goalpost up, and it's like, oh, tree search isn't the problem. If we do a problem that can't be searched, that'll be smart. And then
Yeah,
Denison et al. Beat Go, and they're like, oh wow. Then it's like, I don't know, it's not really that smart, right? And you just move the
right.
goalpost up and up. It's like, oh, we need a computer to do a backflip and walk down the road. You've seen the Boston Dynamics robots
Hmm.
probably that like do all these crazy things. Like, well, it's not really
Right,
that smart. Like, you can kick it and it falls down, right? And so anyway, as time goes on, the goalpost keeps moving up and up and up and up and up and up. And there's a famous philosopher. His name's Daniel Dennett, and he kind of jokes that like all we are just what he calls like a cognitive bag of tricks. That just
hmm
like the AI, like once neuroscience gets advanced enough where like we learn how we work,
hmm
then we would be like, well, we're not that smart. I mean, like, if you saw
right,
my last math test, you would see that I didn't do as good as I wanted to,
right,
or
right,
I mess up
right,
words all the time, or maybe I'm not as smart as we think we are. And so I
right,
think it ends up being like the definition of intelligence in general, um, because we don't have a good, we kind of know what it is. We're like, humans are that. Humans are smart. We can do a lot of things and we built great things. But we can't really even precisely put that into some definition where we have that benchmark and say, once AI hits that, then we've done it. And so, philosophers have tried, and there's been books, and people have said whether or not it's possible for years. And I mean, yeah, it's a subjective thing in the sense of like, when will we actually get there? I mean, people are super afraid of AI. They're like, oh, once it's there, it's already too late. It's like,
I always
isn't it?
say don't run from it, man. Just
Yeah,
embrace
yeah. It's like
it.
if once you learn how these things work now, you will realize that we are
Yeah,
far away from hitting
from
even
takeover,
close to what
right?
we do. Yeah, yeah, yeah.
Right, right, exactly. I agree. And a lot of times people don't understand how AI is being used, and they're using it, but they're thinking, oh, okay, this is just some. I guess they just call it technology or some type of cool advancement, right? I
Mm,
mean, natural language processing is in place in many aspects, right? I mean, just something as simple as like, Google or something like that. What they're doing with like Gmail and things like that.
yeah, yeah, yeah.
And so a lot of people are still they're using it, but they don't understand, right, that it's actually being implemented slowly, right, in your lives,
Yeah.
and definitely impacting you.
And that's what I normally like when I teach it to people. Like what I normally say is like try and ignore all of the fancy like Terminator images or like deep neural networks and complicated math and like all of these like I almost want to say marketing things that have
Mm-hmm.
been put on top of this, even by scientists, because like we think it's cool and it can do something, but like, is it really, strong AI? Probably not. And just to think about like, say like a deep neural network that can, identify images or like a deep fake.
Hmm.
You look at that, that's cool. Like the Obama deep fake was
Yeah, yeah, yeah.
incredible. Is
First one,
incredible.
yeah.
And it's like, but when you take a step back and you actually think about what these algorithms are, is the second you replace every time you hear like AI with like statistical model, I think
Mhm.
you start to make these seem like the more mathy equations that they are. Because
Yeah,
it's not really cognition. Some things are, and in some domains, I think they are actually starting to get close. But the vast majority of algorithms, I think when you just like slip in the word like statistical model, and instead of think of these as like some black box AI and start thinking them more of like y equals mx plus b,
hmm,
then that starts to make more sense. And that's a lot of the times what they are. It's a really fancy way of like trying to find a function between some input data and output data, uh,
hmm.
especially in the supervised sense, right? Like even when you write the neural network equation, it's effectively the equation for fitting data.
Yeah,
Or, classifiers, you're finding a really fancy way in multiple dimensions to draw a line between clusters of features, clusters
yeah,
of, right?
yeah.
Like that's what neural networks got famous for, is that like they could solve the XOR problem where they could add a dimension to data to separate, right? Um, and so, yeah, I think to just try and like take a breath away from the venture capital hype of like, ooh, this is AI, and just kind of like taking stock of what these things really are, will be good. One, from the research side, because you know we want to get there and we will get there, and people are working on to get to that point where these are actually really cognitive machines and are doing
Yeah,
things across the board, not just in each little domain, better than us. It's going to happen. It's probably inevitable. But right now, to not be afraid and not just like hear all of the hype and get kind of like worked up about it, to just really think like these are really powerful tools. They're really powerful statistical tools, and
mhm.
they can be used to do things in mathematics that we could never do before. Um,
Right, right.
and so that's good. But is the problem that these are going to take over the world a bigger issue than a biased data set might disenfranchise somebody? I think the
Mm,
latter is a
great
way
point.
more pressing problem than like dreaming about a Terminator scenario,
Right,
because
because that's going to take. We're not. We probably. I mean, I don't know. I know me. I may not be here during the time that it does take over.
yeah, who
you know,
knows.
I mean, who knows? I don't know. I
We'll
mean,
work harder so you can see it.
what'd you say?
We'll try and work harder so you can see it.
Yeah, 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 exactly. That's what I wish, that I could see something like that. Being able to see AI evolve right now is even amazing. But like you said, there's harder problems to be solved right now, bigger issues to be solved right now, and including AI, right? Within AI,
Yeah.
I've had many people on did podcasts, right, that talked about bias within AI, right, that talked
Mhm.
about
Yeah.
the ethical issues that come along with that, right, and that's a problem that's here right now, needs to be solved before we make some master thing that takes over the world. Because if none
Yeah,
of these
yeah,
things
yeah.
are solved, right, then we're going to probably have a bigger problem, right, in the future.
Yeah, yeah, exactly. And I mean, it makes sense, right? Like if you just told somebody, like, I wrote a model that is going to predict whether or not I hand out loans,
Hmm.
and you say, okay, so how did you build that model? And it's like, well, I just took 15 of the wealthiest women in America, and
Right,
I looked at their qualities, and if you meet those, and you're like, I'm why what does that have to do with me getting a loan? Right.
right, right.
Like a small biased data set will, trickle down and affect everything. And that's happening now. And so I think those are the things to really worry about. And there's, I mean, in the last few years, really good efforts in how to detect it and how to mitigate it and how to, you know, overcome that. I think more than ever. But
And I'm always seeing, I mean, that's a great point that you made, because when you talk about like small data sets, right, being able to be used for big impacts, right?
mhm.
If you're trying to make a huge difference in the world, um, I don't understand how small data sets are even implemented in this place, right? To be able to do that, right? Or maybe multiple, collecting them together. It just seems like how can you make such a big difference, or how can you implement it and change the world with such a small data set? Do you see that happening often?
Well,
That you
well, I think it's, again, I think it's part of this, the disconnect between like thinking of these as statistics, thinking of these
hmm
as like if you were fitting a regression problem, versus
hmm
thinking these as like some abstract AI. Because if you were fitting a regression problem, your like statistics knowledge will kick in. You're like, okay, well, I don't have enough data points. The variance in my data is really low. There's some like bias distribution. The data, right? You would think of all of those like, statistics 101 things that you learn about like what is a good model and those things. But when you think of these as like AI, that's, this is a smart machine that learns from data. And surely this smart machine will be able to overcome those deficits in the data, right?
Right.
Right? Like surely, like when I'm learning features from images, half the time when you don't even really understand what these abstract features are, surely those are the right features because I get 90% accuracy on my data set, or this can beat me in chess, or this can do things better than me. And so then we start to feel like, oh, maybe it is right and I'm wrong, right? And there's no way to really, but again, like if you just think of it as like I'm drawing a line between clusters of data, if those clusters of data are messy, your line isn't going to be very good, and you can't, generalize from the data that you have.
That's a great point. That's a great point. So to close out that one discussion, right? I mean, I
Oh,
just want to make sure that we know what your thoughts are. Will AI take over eventually? Will it take over the world?
yeah. I mean, in some ways, it's already taken over,
Hmm.
in the sense of you know they're building AI into every processor nowadays, right? Like you see it, like the AI chip in your phone, and like neural networks is there, and it depends on like how you define AI. Because 20 years ago, some of the things that are just general computer science, algorithms that you wouldn't even brand as AI because they're not cool anymore. You know,
Hmm.
30, 40 years ago, those things were like huge advances. Um,
Hmm.
and so, I mean, I really think it just depends on what you mean. Usually when people say that, is like, am I going to be a slave to the machine? Like, is it
Right. Or
going
am I
to,
going to lose my job? Right. That's what they care about.
yeah, and it's like if that's your issue, then you might already, in the sense that
Yeah.
like micro trading algorithms, like the flash crash in the stock market, right? It's like that could
Mhm.
have been worse. It wasn't, but people could have lost all their life savings, or a bank might have defaulted, or
Right.
whatever.
Right.
Or you might not even get your job because the resume algorithm might have biased data in the first place, and you won't
Right.
get
Right.
picked.
And I
And
always
so,
say, oh, go ahead. Sorry.
no, that.
Oh no, I mean you make a great point, and I always say that it's not about as the generations, you bring in new generations, right? People come in and they're learning new things, the younger generation, right? it's not about whether you lose your job or not. It's the focus will be different, right? You're going to maybe be the ones that are doing more of the research, being behind the machine, right? And the machine can handle a lot of the automated tasks. That's what I think of, right? They're handling a lot of the
Yeah,
things
yeah,
to be able to crunch everything faster, right? Being able to come up with this predicting the future, things like that. It's great, but you still have to feed it something, right? You still have to be able to do some type of work behind the scenes, and it's figuring out those are the roles that you'll be playing, right? Versus playing the roles that are in the front where the machine is now taking over, right?
yeah.
So I guess that's the way I think of it, right? You're not going to lose your job. Well, the generation now is a possibility, right? But try to
Mhm.
figure out new skills, right, in place
They'll be fine. They'll be
uh,
fine.
to
There'll be a little bit of transitory period, but I mean, my God, when I was in like high school, and like remember like what were the like three things that like your mom would say? She'd be like, "You spend too much time on YouTube. You spend too much time playing video games.
All
You spend
right.
too much time playing with computers." And now you go look at like people who just made $1 million trading Bitcoin, or professional
Right.
YouTubers and podcasters,
Hmm.
and people who are professional game. Like there's a scholarship program at my school for video game, like being a video game player. They give you a full ride tuition as if you were like an athlete for
Oh,
being like an elite esports player. And I think it's awesome. Like you should see the
yeah,
setups that like they have here. Um, but
man.
but like you never know. And I think like I mean AI is great. I love AI, and I watched Tony Stark build Jarvis, and that was like
Right.
I think that's every like young guy out there.
Everybody thinks
I want
that.
that. I want to like walk into my garage and like Jarvis is like, "Hello, Keelan. How are you doing?"
Yeah,
I'm like, "I'm
exactly.
good." Right? I want that, and I want to build that, and I think we are slowly building that. Siri, everything else that we have. Um, but I also think that above all, humans are still the best intelligence that we have, and
Yeah.
we're
Think
creative
about
and
emotions, right?
yeah,
Like,
yeah. I mean, like we're persevere, and we'll solve all of these problems that we have, and we'll think of like new creative ways to make money that like benefits everyone, and use the things at our resource to build. Who knows? So yeah, I think there will be a period where people will, you know, your job is going to be outsourced to a machine, and we need to think about ways to solve that, and re-education, and
mhm.
slowly doing it, or even like basic income, or these sorts of things to like help make that transition less painful for the most people as possible. But I think ultimately that transition, as we've done 1,000 times before, will lead to way cooler things in
Mhm.
the long term, as long as we are conscientious and considerate, and actually think before we just like run 100 miles an hour and like start implementing everything. Um, I think it'll lead to way cooler stuff in the future that we watched in those movies.
Yeah,
10
yeah, yeah. I absolutely agree. Absolutely agree. All right. So, Keelan, you have, I'm sure that the audience right now has been able to say, wow, right? Already, right? But they have not heard what you've done so far as, some of the most interesting projects that you've done, right? They probably haven't been able to do their research and understand that, but
Yeah.
also what's the future for you, right? So what is a project or two that you could say has been your best project so far?
Yeah. Probably the most relevant project to everyone's life
Mhm.
was probably my work on COVID,
Hmm.
um, where by accident, I ended up talking with a bunch of researchers who study smell. And we were some of the first people, like, COVID, the strongest neurological symptom of COVID was loss of smell and taste. That was like the
Hmm.
standout symptom. Everyone was on TikTok, and everyone was on like
Right.
a bunch of celebrities who were out there saying like, I lost my smell and taste. This is weird. A lot of my friends and family did. And so we were some of the earliest researchers to really collaborate globally and internationally, and develop a big research consortium to try and understand um, what caused loss of taste and smell, and what are kind of what's the time course, and is it just smell, taste, or there's actually a third sense called chemosensis, which is spicy foods. It's like a third nerve that goes up to your head. And so, yeah, that was really, really interesting to see, because like most of my stuff is like esoteric in science, and it's like there's like some cortical oscillation that travels in a certain direction in your head, and it's like the few people in neuroscience really think that's dandy, but like if you went to the public and said that like this oscillation goes in this direction, people don't really like get that. I mean, I love my neuroscience research, and that's what I'm going to do in the future to answer that question. That's where I am. But it's kind of cool to get a taste of like what does science in a really big world problem look like, and to see that kind of direct impact and not that delayed impact that you usually have in science, where like you're doing work and it doesn't really pay off for a few years. And so, to see press and to see like thousands of visitors visit a website that I built, and to analyze some data from, COVID patients like who were right on the front line. And then we also built like models that could use the taste and smell data to help predict the spread of COVID. And we even found out that taste and smell was a better indicator of COVID spread than some of the traditional metrics that the government was using. And so some of our papers even got cited in, I think, some like European government literature on like how to handle the virus. And just to see that impact of like, I'm typing things on my laptop to, the New York Times is writing about us, and this government is saying that this is a useful metric, and seeing like the symptomology of COVID go from, fever, headache, sore throat, to loss of taste and smell, that just kind of started getting implemented on there, was really, really cool to see. And kind of, sometimes you kind of get like lost in your room. It's like, does anything I do really make a difference? That was one of the first things I actually felt that like what me, and especially like it was not just me, it was a collaboration of hundreds of scientists and doctors and patient advocates all working together to kind of like make this thing happen across the world. Was incredible. Was like probably one of the coolest experiences.
No, that's awesome. I mean, that lets you know that what you're doing is making a difference, right? And that's important. Do you so based off of that, right? There's so much more to be done probably with COVID, but I know that you have so many different ideas, so many different things that you're probably spinning through your head right now. You might even came up with an idea just just as having a conversation and said, "Man, I need to do this." What about the future, right? Where does Keiland see himself? What kind of research do you see yourself doing, or projects, in the future, right?
Yeah, I mean, the stuff I'm doing now is where I probably want to be long term. This we have a big paper that's about to be published, where we're, like I said earlier, we're applying like deep neural networks and some like AI models as tools to help understand neuroscience data. So most of the time, what I study, most of my time is studying is how we learn and remember in the brain. And so we record the activity of neurons in the brain, and then we take that activity and try and decode it and make sense of like, how is the brain, forming memories, or how is the brain learning, or those sorts of questions. And I think that this kind of intersection between neuroscience and AI is incredibly powerful, and it's only going to get more interesting in the future as AI gets better, and as we start to solve some of the problems that are plaguing AI with new ideas from neuroscience, as DeepMind has shown as like the best case study of this in the world. Because the CEO of DeepMind, he was a PhD student in neuroscience. Yeah, and he was a great chess player. Yeah, Dimas Hassabis, he was a PhD at London, UCL. He worked with a woman who did a famous study on the hippocampus in taxi drivers. That showed that like people who learn spatial maps of the world have bigger hippocampus, which is important for memory than other people. He also did a study where he showed the coolest study in neuroscience he probably did was that like Alzheimer's patients, they
Mm-hmm.
can't imagine the future as well as people who don't. So like Alzheimer's affects the hippocampus and brain areas for memory. And what it showed was that your imagination and imagining the future and this like creative capacity that we have is really dependent on the same brain areas that are important for memory. So like the theory goes that like what creativity is you're just taking your memories and you're shuffling them around in some way. And so that was like some of his big neuroscience work. And then he, said, "Oh, I bet I could apply this to AI. Beat Atari, beat Go, solve
Right.
protein folding." So anyway,
Yeah.
it's in all of the models. When you read their papers, they say biologically inspired, episodic memory inspired, biological replay, reinforcement learning, which derives from a lot of animal literature. So very biologically inspired AI company that probably the world leader in advanced AI technologies.
Man, that's awesome. I mean, you just gave me a lot. I can't wait to replay this to myself about 100 times so that I can go back and do some more research on my own.
Yeah.
So diving into cognitive like research, right? When we think
Mm-hmm.
about like AI versus computing, right? Yeah, cognitive computing at some point, cognitive AI, not to dive too deep into it, but I'm sure from my point of view, I know I dealt a lot with cognitive AI in the past, I mean, cognitive computing more than AI, right?
Mm-hmm.
In the past, I think about like how to mimic human behavior,
Yeah.
at some point, right? Um, where do you see some of the differences, right? You have deep learning, NLP, right? You got neural networks, but there's so many differences between that cognitive computing and cognitive AI. Could you help the audience with what your thoughts are on that?
Yeah. I mean, I'll ask you first. Like, what do you think the differences are? Like from your
So I see like,
like what's your gut feeling of like this is like what I think?
well, like I said, when I think about computing, I think about or cognitive computing, I'm thinking about uh, somehow trying to take this machine or something, trying to mimic that human behavior, right?
Yeah.
Solving some complex problems. But when
Mm-hmm.
I think about with cognitive AI, I think about like um, finding some of the patterns to learn or reveal like the hidden information or finding solutions, or I think about like solving some complex problems as well, but with like AI augmenting some of the human thinking, focusing on um, like providing accurate results, like being more accurate with results, over time or
Yeah.
something, you know. I mean, does that
No,
seem
yeah,
like,
I think yeah, no, that's pretty much how I'm thinking about it. And maybe I would only reword it in the sense that um, I think when we think of like cognitive computing, we think of like computers solving problems that were traditionally human only problems in kind of whatever way problem. So like Jeopardy, for example. I mean, IBM Watson is probably the biggest like brand for this cognitive computing like,
Mhm.
field. Um, but like I was saying earlier, when you kind of like open up the hood of Watson when they played Jeopardy, you see it's like database search, and it's just searching through like it's learned Wikipedia pages.
Right,
Is that really cognition?
right.
Maybe. Um, and so I think that would be kind of like this cognitive computing in the sense of AI, where we're solving these cognitive problems, but really by any means necessary. Like we really don't care if the algorithms are biologically plausible. We don't care if these algorithms work the same way that we do. That we can play chess however we play chess, or you can play chess by just searching all the possible moves and seeing which trajectories are most valuable.
Mhm.
Both are equally valid ways of playing chess. Some have their advantages and disadvantages. Where I think cognitive computing or cognitive AI is this idea of building some artificial intelligence system that does some form of the thinking process that we do to solve the problem. So instead of just,
So removing that role of the human, right? Or
Yeah.
minimize at least, or somehow.
Yeah, and I mean it'll vary by depending on who you talk to and what their field is and how they view, the whole, somebody from IBM is probably going to approach this very differently than somebody who wants to build a general intelligence. But I think like the grand goal of AI to build this artificial intelligence that is at least equal to whatever we are, whatever our intelligence or our cognition is, however you personally define that for yourselves. Um, I think to try and dash a little bit of that into your algorithm, to put a little bit of that thinking process and that cognitive process that we do, that kind of goes above and beyond. And we don't know how we do it. That's why neuroscience is a field. That's why we're still publishing papers. And so again, the benchmarks are really hard to define because you don't know what it is you're trying to meet. You kind of have some idea of like, oh, I want to solve this really hard problem, but you don't know if that's really how we do it and what the advantages and disadvantages of ours are. And so I think to try and think about how to build an AI that can sprinkle that cognition that we've learned from a few hundred years of psychology into these problems, and to do some of the things that like we can do better than the existing algorithms is probably my personal definition of what cognitive AI would look
I
like.
think that's a great definition right there.
I mean, it'll boil down to like Jarvis, right? It's like when you hear Jarvis in Iron Man, he sounds like he knows what he's talking about. He
Right.
sounds like he has agency and a goal and a plan, and has like some memories that he's experienced, right? He knows that Tony Stark is kind of sarcastic, and so he jokes with, right?
Mm-hmm.
These are like the little things that like if you were playing chess, you would know that your opponent likes to be cheeky and do like little moves to spite you, or he really, I don't know, the human side of things, like you said, emotion, like really that's what
Yeah.
it is. When someone's trying to piss you off, or when
Right.
someone is trying to like you, or make you happy, right? These sorts of things, where like graph search cannot do that, or maybe you need to write it in explicitly, but like the cognitive AI would have this model of the world. Maybe that's what it is. It's this world model, this like statistical model of how the world is working, that it's constantly building for itself. And because
Right.
of that, you make predictions of how the world's going to work. It can edit those predictions. It can apply them to new domains, new problems. And because of that, it can do those sorts of things that a traditional like savant database algorithm just couldn't do.
No, that's a great point. I definitely think that definition is straight to the point. It's amazing. I think the audience will definitely grasp exactly what you're talking about.
Maybe.
And
I don't know if I
I
grasped it.
think they will. I mean, maybe because I'm pretty technical and I understand it, maybe I
Yeah,
grasp it more. We'll see. We'll see. We'll get the feedback.
yeah,
I'll let you know what to say. But I'm pretty sure we have a pretty technical audience that really loves to hear the experts communicate their thoughts on some of these things.
yeah.
Uh, and so, thank you, right? And as I always end, right, some type of dope gem or nugget. And what I've learned today, Keelan, man, has been, when I think about artificial intelligence, and I would say, at one point, I didn't think we were at this phase, right? I know we work so hard to get to AI, right? We're working harder to advance it. I just didn't think we were that far along until I did a lot more research, over the more recent months to focus in on that aspect, right? And when I look at artificial intelligence, I see that we are really getting closer and closer to forming the basis for all like computer learning from a sense, right?
Yeah.
And it's the future, right? Being able to make complex decisions. And when we think about deep learning, we're really focusing in on how we can set that foundation for future of business decision making. You
Yeah,
know, and
exactly.
and
Yeah.
and I love what you said. Is there anything that you want to leave the audience with before we get into our game, man? We're about
Yeah. So yeah, like you said, hopefully this resonates with some people in the audience. But this is a one-way conversation. It doesn't have to be. So if you have questions or you want to learn more, my email is, or how about my website? I'm sure you'll make that available. That's best way to get in contact, reach out. I'd love to talk about it and clear up some things that I rambled on about, or
Yeah,
tell
yeah,
you more about how we can make AI work for you,
definitely,
not
definitely.
the other way around.
Right, right. Yeah, so many people think that it's going to take their lives away, but you're right, making it work for you, kind of working side by side with that.
Yeah.
All right, let's get into some of the fun stuff, right? A game
Yeah.
called Overrated, Underrated. I've been doing this for about 30 podcasts. I
I'm ready.
like to ask the experts some fun stuff, right? Not to get all deep and technical like we've been doing this whole time, but just to get to know the expert, right? Behind the scenes, like what do they like to do and what their thoughts are on things that are kind of fun to some people outside of just techie stuff all the time.
Yeah.
And so I ask you a question, I'll say, hey, look, do you think this is overrated, underrated? And you say it's overrated, you say it's underrated, or you say it is exactly where it needs to be. You can explain why if you want, or we can just keep moving to the next one, right?
I'm ready.
All right. First one, social media.
Underrated.
Underrated, underrated. Okay,
The
okay.
power of social media, I think, is underrated. Yeah.
I completely agree, man. I've had guests on there that said it's overrated. They're like, but then you got to think about generations, right? Some people will say it's overrated,
Yeah.
for sure, the older
I'm just
generation.
thinking of it in the sense of globalization. I think this is like a paradigm shift in human communication and globalization that I don't think we really quite get that yet.
Yeah.
The fact that I can have a conversation with somebody in Africa one day and the next day I can have a conversation with somebody down the road and not really know the difference anymore.
Hmm.
Yeah, that's something that humans, and the amount of information
That's
people,
great. You're right.
yeah.
All right. Next one, the printer.
Underrated. That was like the first thing that made the virtual space of computing real, right? It's like before then you just like design something on a terminal, but then afterwards, like you could hold it. That's how they marketed it, right? They're like
Yeah,
you can
yeah,
hold that in your hand. Yeah,
yeah.
underrated. Yeah,
No, I agree. I mean, I guess I have two sides to that. To me, it's like, all right, who uses this printer thing anymore, right? But
well, the
some
second
people
you have to buy ink, that's when you realize this thing sucks.
right, right. All right, so higher
Nowadays
level,
maybe overrated. How about that?
yeah, nowadays, yeah, yeah. All right,
3D
higher
printing,
level education.
higher level education,
Mhm. I only
probably.
ask this question because I think about you have some of these people who have come up with these amazing, innovative ideas, right? And they never finish, right? Some of the higher level education, but then you also have people that have gone through the ranks, right, and
Yeah.
still have. So I just want to know your opinion, right? Just off of it.
Well, it's like I'm thinking of that, like, programmer who taught himself how to code in high school and then he gets like 150,000 job at Google.
Right.
Like, did higher education serve him? Probably. I would say it's overrated for the people who just think you have to go through the ropes to get a degree to get a good job, which unfortunately is, the truth of how
Exactly.
things are a lot of the
Society
times.
is like that, right? They
Yeah.
make it like, yeah.
Like it's just a means to an end. So yeah, I don't know. Depending on your situation, it might work for you and what you want to do. But I think it's underrated for people who really like to learn about stuff, because you
Mhm.
are just thrown in an environment with some of the smartest people in the world who just have a playground of some, like, the intersections of all the best things about humanity, right? It's like
Right.
one building is biology, one building is the arts, one building is some guy who spent his whole life thinking about like how frogs walk, right? Some
Right.
like esoteric thing like that. That like he's the world expert on that thing. His passion
Mhm.
is that. And that is just a really cool thing that I know there's a lot of hate for university right now, but just knowing that potential of what it could be when like really smart people hang out.
Yeah.
Yeah,
No,
it's
I agree.
underrated.
I
Yeah.
completely agree. So I already know what you're going to say about this one based off of what you
Uh,
do already. But research.
underrated.
Underrated, man. It is completely
Yeah.
underrated. In my eyes, when I look at it, just real quick, I think about how the younger generation, right? The elementary school kids. I mean, that should be probably the number one class that should be implemented into some of
No,
these.
no, they don't need it. They don't
Yeah,
need it. The younger kids are fine because they do it right? Like you've talked to you have kids, right?
yeah, yeah,
They're inquisitive all the time, or they ask you like questions about the most random stuff, putting stuff in their
yeah.
mouth, like
Yeah.
breaking things to see what, right? We're not. It's after that where like we somehow devised the best system in the world to beat out inquisitiveness of people.
Mm,
Like sit in your desk, do what you're told, just do what, like I was saying with education, just
yeah,
do whatever you can to get the grade, to get out of here, to get a job, to support your family, which, for most people you got
right,
to do. But there's another way where you can, like what you do along the way and explore the
right,
world and be happy for it. And
right,
so
all
that's
right,
our fault. That's our generation above us fault that we somehow did that to those kids.
right, right, right. All right, I got two more real quick.
Yeah,
Zoo,
fast.
the zoo,
What'd you say?
the zoo.
Underrated. Well, sanctuaries are underrated. The
Uh,
zoo, it depends on how it's ran. Okay, sorry.
all right, and then lastly, grilled cheese sandwich.
Underrated.
Ah, man, yeah, yeah, I agree, I agree.
That's the go-to.
It's a go-to, man. It's a go-to,
What's
man.
the easiest thing you could eat at like 2 in the morning?
Who are you telling me? If you make it just right, I mean, it's mind blowing, right?
Yeah.
All right, all right, okay. So thank you again, Keelan, man. You
No,
have been
thank you.
awesome,
This was so
awesome
much
guest.
fun.
You
Yeah.
know, I definitely think we should keep in contact, man. And
Oh
I
yeah.
appreciate you being on the Data is My Science podcast, the show that makes data your passion. I'm your host, Dapper Data, and Keelan. Where can they reach you at again? LinkedIn or anything like that?
Yeah, LinkedIn, my website, kwcooper.xyz or kwcooper.com, both points, same place. Or just Google my name. It's a unique name. It's a new
Yeah,
name.
yeah.
It's hard to pronounce, but easy for SEO. So, yeah, yeah, I should pop up. And thank you, Mr. Dapper Data. This is
Yeah.
like the coolest thing that you're doing, and
Thanks, man. Thanks,
I'm
man.
now I'm a fan. I'm a committed fan. I will tune
Oh,
in.
I appreciate it, man. I appreciate
Yeah,
it, man.
yeah.
Is there
Everyone should.
lastly, is there anything that you want to promote or anything like that that's going on coming up soon?
Not much for me. In the science world, we're about to publish a big paper. So if you happen to be academically inclined, stay tuned.
Yep.
If you're interested in AI, head over to Continual AI. It's just a community of people from all walks of research and industry and academia and just, high school kids who love to code. So hang over to that website. That's continualai.org.
Yeah.
And hang out with us. That's what we do. We just talk about AI and build cool things. And yeah, learn to code if you haven't already, because that
Right,
will
right,
change your
right.
life.
Always promote that. Well, thank you again, Keelan, man. I know we got a hard stop, man. So I want to make
Yeah,
sure that the audience knows. Definitely check out Keelan, man. I appreciate everything you're doing for the AI community, neuroscience community, and data community in general. And audience, you can meet me at Mr. Dapper Data. .com at Mr. Dapper Data on any one of the social media platforms. Love you all. Peace. All right.
yeah. Bye. Thank you again.